So my hobby that I'm doing for the extra credit is tennis. And I feel like this is a really good hobby to have in this scenario because there's so much physics in tennis and stuff. And I'm sorry that my room is very messy. Don't look at it. Okay. So from like the techniques, like the certain way you hit, the way you hold your wrist, the angle, just all kinds of things you do in tennis. I feel like they all kind of relate to physics. And one of the most prevalent aspects of physics displayed in tennis could be the first law, or the law of inertia. The inertia, it states that an object or mass will remain either at rest or in motion in the same direction unless acted upon by an unbalanced force. And so this means when a tennis ball is hit at you, it's going to remain in the motion it's in unless acted upon by an opposite force. And in this case, the opposite force is your racket hitting the tennis ball and causing the ball to move. And yeah. So the next aspect of physics that I'm going to be looking at with tennis is the force of the ball being hit by my racket, and specifically when I serve. And I calculated this by using the equation F equals mass time acceleration. And in tennis, you have what's called a first serve, which is usually harder than your second serve. And it's either with top spin, a slice serve, a kick serve, or a flat serve. And you use a different grip depending on the thing you're trying to achieve. But overall, the objective of the first serve is always to ace your opponent, which means you hit the serve in the box and you make it in without them being able to touch the ball and you get the point. Most of the time that doesn't happen, but you hit harder and you use the certain techniques in order to hopefully ace your opponent. And so the average acceleration of a serve for a woman is, for a professional woman, is 51 meters per second, but the average acceleration of a tennis ball on a serve for a girl, for like me, is 31 meters per second. And so the mass of the tennis ball is 0.0057 kilograms. So the force of my first serve is 0.1767 newtons. And also, you have what's called a second serve, which means if you don't make the first serve, then you get to try again. So hopefully you won't lose that point. And the point of this serve is you change your grip and you just try and get it in, so you don't lose the point. You still try and like hit a good serve, but you're not as focused on winning the point as you are getting it in, so you don't automatically lose it. And usually, so these would be slower, and so the acceleration of my second serve is closer to 28 meters per second. And so the force of this serve would be 0.1596 newtons. And I'm going to add in first a video of my first serve and then a video of my second serve. Okay. So to continue the talk about the serve, so when you are about to serve, or when you have your hands down at the bottom with your tennis ball and your racket, your feet are supposed to be behind the line, and they're supposed to be starting separate. They're supposed to be the right foot or your dominant foot in front and the other one in the back. And you're supposed to lean all of your weight on your front foot as you lean forward. And as you throw the ball up, you're supposed to shift it to your back foot. And also, you end up putting your feet together once the ball hits the top of, like, the highest point that it will be thrown in the air. And at that point, you have your arm back here and your legs are together, and you squat down and you have your arm in the back, and your hand is going to be like this. It's supposed to be bent back, so that way when the ball is at the top, you can swing through the ball and you accelerate your wrist super fast. You whip it out, and you do this, and you jump up at the exact same time, so you can have as much acceleration possible, and you can whip it forwards and drive it as far as you can into the box, so it will hit the hardest. And also, this is the same concept with the backhand, because you start with both hands like this, and then you whip it forwards as soon as you make contact with the ball in order to push it forwards. My final aspects of physics on tennis is that a tennis ball hitting a racket is an example of an elastic collision. And this is experienced when an object makes contact with another object and then they separate, leaving both objects with the same amount of kinetic energy and momentum that there was in the beginning. Basically, there is no loss of any energy, as energy cannot be created or destroyed, and this is stated in the first law of thermodynamics. So, when a ball is hit to you, the ball and the racket make contact, and instead of staying together, which would be an inelastic collision, they separate and both energy is left. So that is why it would be an elastic collision.